So first of all, I wanted to talk a little bit about planning for potential failure. How do we build this in? With innovation, it's always a risk. Innovative in analytics. So what can we do about it in advance? And then Alan's going to provide an example whether we really applied that with the radiotherapy workforce planning tool. And then we're going to draw on our reflections on that project. So I think the first thing is we've been aware that failure is a possibility. We know that things don't always work as we've heard today. And we know that there's that risk with things, particularly the more we're pushing, the more innovative it is, the newer it is, maybe there's a higher risk. But what can we do to minimize this risk, both structurally and also in the way that we actually approach the analysis? And actually, how can we use this? And really, how can we embrace uncertainty around some of our projects? Alan's going to talk about the radiotherapy tool and the complex problem it's aiming to solve, and the role of the scoping and how the challenges have changed the way the tool has worked, and how he's had to adapt the approach. And then we're going to reflect on what we've learned, what we can apply to other work, and how we can actually celebrate the success from our projects. So I think when we're planning a project, when thinking about work, what kind of failures are we trying to plan for? So we've got failure to understand the need. What is it that our piece of analysis is really trying to understand? What decision is going to be made? And sometimes that can take a lot of work to really understand exactly what's needed. And if we don't understand the context in which that decision is being made and all the opportunities around the existing data, we might fail to design our piece of work to really hit that and hit those needs. Sometimes I think we fail to actually spend enough time working out what's the specifications of this piece of work, and working with the customer, the end user, and what is it that this needs to do. And failure to look at particularly different approaches that may be able to meet that need. Do we necessarily need to go and build something? Can we adapt something? And of course, as we've heard, there's failure in execution and failure in quality. So how do we address some of those? So the first thing is really listening and questioning, understanding what it is that people want from the tool that's been developed, and investing the time in the investigation, discovery of the background, the real needs. And that comes to a comprehensive specification that we can work with the customer to be able to say, is this what you want? And if not, this is great opportunity to feedback and try and describe the work before it's built. Obviously, we can do an options appraisal to work out the best approach. And then in the execution, we need time planning and actually technical skills. And what technical skills do we need to be able to deliver the particular piece of work that's required? And of course, we've got our quality assurance processes for quality. So what do we do in practice? I think, first of all, we accept that it's possible. And we invest time in detailed specifications, and then we iterate with users constantly. And drawing, as has been said earlier on, from the software colleagues, software development colleagues, it's about building a wireframe. What's a minimum viable product? Can we do something if we're doing it for all trusts in the region, for example? Can we do it for one trust just to see what it looks like? Does that meet the needs? Does that answer the questions that need to be answered? Working with that co-development, and then testing new ideas and approaches that emerge, and new opportunities that come up, and making active decisions about whether actually this is the way to change what it is that we're doing and revisit those specifications. And what we can do is plan those development stages and review stages as part of the project in advance. We know that we're going to do some work to investigate. We're going to put a prototype up, a wireframe for people to look at, and then we're going to have another version before we look at quality assurance processes. But even with doing all that, which I'd like to think we do for all of our projects, things may not run that smoothly. I'll hand over to Alan, who will talk a little bit more about the radiotherapy planning tool.
Thank you, Glenn. So good afternoon. My name's Alan. So I'm an advanced analyst within Glen's AES team at Health Innovation East Midlands. So as analysts, we often juggle complex workloads of concurrent projects. One such project was the development of a radiotherapy workforce planning tool. It was a typical request that turned into an intricate challenge. So before we begin, just a bit of context. This is a screenshot of the radiotherapy model, which I'm going to use as a subject for my talk on failures. It was produced in collaboration with the East Midlands Radiotherapy Network and University Hospitals Leicester. This is an overview page of the model. Each coloured arrow in the worksheet, each coloured arrow is a worksheet within the model. So we've got blue, which is the instructions and notes, yellow, which is the baseline and baseline analysis, green, the growth model, including the assumptions, adjustments for episodes, fractions, and duration. Purple was a summary of the demand, which flows through from the green worksheets. Red is the capacity calculations and adjustments, and also the gap analysis. We've then got orange, which is the staff costings, workflows, and safe staffing levels. And black is the tables and lookups. So next slide, please, Glenn. So the purpose of which is to evaluate the demand requirements of the radiotherapy pathway, the capacity needed to sustain this, and a review of the current radiotherapy workforce gaps. So as you can imagine, radiotherapy is under immense pressures from increased referrals, growing waiting lists and staffing levels. It's also worth pointing out that there are several radiotherapy models out there, but they are either static with no facility to update and hence quickly become out of date, or complex and not easily adjustable. Next slide, please, Glenn. Thank you. So, as mentioned, the model is made up of several dependent modules or sections. Any changes or assumptions or adjustments made to one section flow through to the other parts of the model. The idea was to make what is a complex and dynamic pathway easily adjustable. For instance, advances in radiotherapy technology and treatment intent, whether that's curative or palliative, and patient physiology impact both the frequency and duration of individual patients' treatments. This model makes those adjustments easy, but also ensures that the model is future-proof beyond its current forecasting years. Next slide, please, Glenn. So, early scoping provided critical clarity and helped to mitigate misaligned objectives. So, two key risks included stakeholder miscommunication, so misunderstood objectives can result in inappropriate models, or unclear problem definition. A poorly defined scope can lead to unfocused or unhelpful outputs. Additionally, scoping highlighted the balance between overfitting, producing an overly complex model that fails to generalize, or oversimplification, models that miss critical nuances. Next slide, please. Some of the main challenges, accessing NHS data posed significant hurdles. So initial reliance on national radiotherapy datasets, the RTDS, due to delays in data sharing agreements, revealed that the data lacked the granularity required. So gaining insights into departmental data systems required close collaboration. For instance, I'm not an expert in the clinical systems used by UHL, therefore it's critical to get local knowledge of the systems used. In this case, it was ARIA, which is an information and imaging management system for all aspects of oncology care. However, other trusts may use different systems, such as Nottingham, which uses Mosaic. What was clear is that building early relationships fosters trust and understanding. Next slide, please, Glenn. So I also encountered several early challenges, mostly involving around the data extracts from ARIA. There were several issues that hindered the modelling. So we had noisy data, so excessive variation, masked trends, sparse data. At the level of granularity that we required for the model, we had gaps and missing values, which again caused issues with forecasting reliability. We had inconsistent data, so differences in formatting and measurement scales, and non-stationary data, so changing statistical properties complicated forecasting. So the non-stationary data is basically data that's statistical properties that change over time, making it unpredictable and difficult to analyse. For these reasons, it was incredibly difficult to sort of forecast using statistical forecasting techniques. It became very clear that the outputs were not suitable for our specific purposes. And we also had additional challenges as a result of COVID. So COVID-19 further disrupted the data reliability with reduced case numbers, rendering historical data and trends less applicable. Next sheet, please. Radiotherapy involves numerous variables, so tumour type, location and proximity to vital organs, treatment intent, whether it's palliative or radical, equipment differences, so linear accelerators that might have subtle differences in each Linux machine, protocols such as hyperfractionated radiotherapy, so smaller amounts of radiation more frequently, and frequent changes due to research or patient-specific needs, all of which requires different levels of radiotherapy doses or fractions, and all add to the complex mix and frequency of fractions and durations spent having those radiation doses. The model needed to address these complexities, but somehow make it easy to adjust. And a site visit was pivotal to my understanding of that complexity. Next slide, please, Glenn. So the model needs to consider demand, that increase in population, changes in prevalence rate of each tumour site, changes to treatment regimes or for specific tumours, or variation of treatments for each patient. So not a standard model for everybody, but proportion of patients having a set number of treatments, etc. The model also needed to consider the capacity, so core departmental hours and adjustments for out of hours working, departmental efficiency in things like planned and unplanned machine downtime, department staffing, including bank and overtime hours, the number and changes in linear accelerators, so when machines are brought online and when they're decommissioned, etc. Next slide, please, Glenn. So to address these challenges, we focused on alternatives such as aggregated growth rates for population and cancer incidence, rather than statistical forecasting predictions, which we applied to episodes rather than attendances, as these were less likely to be affected by COVID, while at the same time overcoming the problem with sparse, noisy and inconsistent data. The key adjustments included using population age and cancer incidence projections to estimate episodes at a financial year level, converting episodes to attendances or treatment fractions, which could be adjusted for treatment complexity, and factoring in a new unit created for the tool, which was machine units of 5-minute increments used to model both demand and capacity. Excuse me. This minimised the impact of the limitations of the data and simplified a highly complex system. Next slide, please, Glenn. Oh, and sorry, and the next slide as well, please. That was just a screenshot again. So the key lessons learned. So underestimating complexity. The intricacy of radiotherapy process was initially underestimated, leading to delays in and redesigns. Collaborating with stakeholders, so departmental visits and stakeholder engagement were essential to navigate those challenges. And then balancing simplicity and detail, simplifying a complex department's operations into an adaptable model proved effective. Thank you, and that's me.
Sorry, I failed to come off mute then. Did we plan correctly? Well, we knew that it was a risk. We specified, and we spoke very, very closely with users to really understand what was needed. A wireframe, not so much, but an early draft, certainly. Definitely co-development. The only reason it's been successful is because we did and work very closely with those using it. And we tested those new ideas that had to emerge in order to be able to deliver the tool and actually produce something that was useful. And we did plan those stages, and we are going through QA at the moment.
Glenn, I think you've gone back on mute.
Apologies for that. Thank you. Don't quite know what happened with then. So was it a failure? Well, does it, in answering that question, I thought, does it deliver something useful that's not been done before? And yes, it does. But was it easy, quick? Did we get it right first time? Not so much. Did we know it was going to be complex? We absolutely did. Did we know it was going to be that complex? I'm not so sure. But ultimately, is this seen as something that's truly valuable and delivers something that people have struggled with? Well, yes, the feedback we've had so far is this is useful. It's a hugely complex model. Radiotherapy is hugely complex. And I think in that environment, it is welcome. So in terms of the output, I think it has been. In terms of the project plan, perhaps less successful. Apologies. Teams is playing on, keep putting me on mute. I think it was a function of the complexity. So yes, we underestimated the complexity, but we did fail to give up. And testament to Alan and his perseverance and lots of head scratching to solve these problems, the multiple problems, to get a tool that works. In reality, I would regard it less as a failure, more general learning as part of the process. It needed to be iterative. We knew we were going to have to learn. It was more complex and more iterative than we thought it was going to be at the start. But the understanding and support of the person that commissioned the work was absolutely essential in the teams, recognizing that as things moved on, that we needed to ensure that we delivered something that was useful and was usable. And so that understanding, not just in terms of helping with the design of the tool and what it needed to do and how it would do it, but also the flexibility in terms of timescales and what was happening. And also giving us access to people that can really have a look at this, providing their input and to see how it should work. Could we have predicted those potential issues? We could up to a point, but there were more than we anticipated. And I think the biggest failure was underestimating the time required, both the task time and the process time in order to deliver that. So reflecting this as a team, one of the things that we recognise is that the key learning is there's a risk of around communicating failure with stakeholders. How do we tell people this is not going to plan? We're concerned we might not be able to deliver this, and we certainly can't deliver it within the timescale we thought we could. I think one of the risks is to fail to acknowledge that it's not gone well or gone as well as it could do. And I think that's a real risk. And I think that was mentioned earlier on. And so culturally, it might not be acceptable and within teams not to accept. And I think that's a real risk in those environments where it's unacceptable to acknowledge that. I think it should be, as Chris mentioned earlier on, it should be encouraged for people to say, actually, this isn't going as well, and be supported when they do, both emotionally and practically. We also need to find out what went well to avoid failure. So what did we put in place to actually stop things from failing? And that links back to obviously professional development of that and that essential professional practice of that reflective practice. And we've heard some good suggestions about how to do that a little bit more objectively without beating yourself up too much about it, and recognizing that sometimes there is an element of things not going well, particularly when things are innovative. So what has this project confirmed? Invest time in developing specifications. Had we not spent that time at the beginning, I think it would have taken, in fact, I don't think we would have been able to deliver something. I think that time that Alan spent really understanding what the problems that the tool needed to address was absolutely essential. You need to test assumptions and design and outputs regularly. This is what we're doing. This is what we're thinking. Does this make sense? Does this work? And this idea of failing fast, and it's a very, very trendy term. But what I mean by that is what can you put in place to know that it's not working early, rather than waiting till get in the end and put the whole thing together and say this doesn't work, but actually work out what bits do you need to put in place. So testing those assumptions first, and can we validate those? Understanding of the customer and why, what they need in that co-design essential, and embracing that complexity where complexity is needed, and recognizing that it is needing. I think understand what will be done and go and see it. I think Alan has often talked about how important it was to go and see the radiotherapy department. I think one of the key failures that can happen is the failure to learn from those opportunities that any failure provides. And thank you for listening, and I'll hand over back to Kev.